Hello students and good day. You are welcome to CHM 191 Introductory Practical Chemistry 1 class. CHM 191 is a practical chemistry course based on CHM 101 Introductory Inorganic Chemistry and CHM 103 Introductory Physical Chemistry. Before I proceed further, let me introduce myself. My name is Dr. Kele Henrietta. Our first experiment in this course is experiment 1, titled Preparation of a Solution of Known Concentration and Obtaining a diluted solution from the original solution. As you know, before we go further to explain what a solution of known concentration is, let us recall what a solution is. Remember, a solution is a homogeneous mixture of one or more solutes dissolved in a solvent. A solute is a substance that dissolves in a solvent to produce a homogeneous mixture. It can be a solid, a liquid, or a gas, while a solvent is a substance that dissolves, while a solvent is the substance that the solute dissolves in to give a homogeneous mixture. It can be a solid, a liquid, or a gas. Now, let us go back to our definition of a solution of known concentration. A solution of known concentration is also called a standard solution. A standard solution is one in which the precise concentration is known. By this, we mean that the exact amount of solute that is dissolved in the solvent is known. Standard solutions are normally prepared using the primary standards. Primary standards are reagents that have high percentage purity of, say, 99%. They are stable. That is, when exposed to the atmosphere, they remain stable. They are soluble. They are known by known stoichiometric equation. Now, standard solutions are used to determine the concentration of other substances whose concentrations are not known. The concentration of standard solutions are normally expressed in molarity or normality or formality. In general chemistry, molarity is the most commonly used concentration unit. If you recall your molarity is moles of solute over liters of solution. That is mass in grams all over molar mass, gram per dm cube times liters. It can be expressed in moles per liter, moles per dm cube, so forth and so forth. Today, we are going to prepare a standard solution of sodium carbonate. By the end of this experiment, you'll be able to know how to prepare a standard solution of sodium carbonate, and the knowledge gathered from this experiment you can apply to other preparation of standard solutions of any given substance. For this experiment, we'll be needing the following: chemical reagents and apparatus. The chemical reagents we'll be needing is anhydrous sodium carbonate. Our apparatus will need 10 cm cube beaker, 250 cm cube beaker, 250 cm cube volumetric flask with a stopper, evaporating dish, oven, desiccator, analytical balance, glass rod, glass funnel, wash bottle, funnel stand, spatula, and deionized water. Now, we need to take into consideration some safety tips. Remember, the laboratory is a place filled with glassware and a lot of corrosive chemicals. So it is important that when you are in the lab, you take great precaution and avoid spilling chemicals on your skin. Now, let's go to our experiment. Our experiment, what we are going to experiment on is we want to go, before we want to experiment on, we want to prepare a standard solution of 1 molar sodium carbonate. And to do this, we follow the following experimental procedure. Now, remember, like we said in our earlier introduction, that standard solution is a solution in which the precise concentration is known, meaning that the exact amount of solute that is dissolved in a specific volume of solvent is known. So that means for us to prepare our standard solution of sodium carbonate, we will have to determine the exact mass of sodium carbonate that will be dissolved in a specified volume of solvent, which is 250 cm cubed of deionized water. To know and why we are going to determine the mass is because sodium carbonate is a solid. So we will need to know the weight of the solute of this sodium carbonate that we have to dissolve. So to do this, we apply the molarity concept. Remember your molarity concept, which is moles of solute all over liters of solution. So in doing this, we will have to make the mass the subject of the formula. And from these, we will get to know, you would get to know that your the mass is molarity times molar mass times liters of solution. The molarity, the molar concentration we want to prepare is 1 molar. So the molarity here is 1 molar sodium carbonate. If you work out the molar mass of sodium carbonate, you get 106 grams per mole. Now, when you substitute in the equation provided, you will get 26.5 grams. Meaning that to prepare this 1 mole of sodium carbonate, you weigh accurately 26.5 grams of sodium carbonate. Having done this, we go by the following experimental procedure. First and foremost, we will have to, because at times during production, the sodium carbonate might still contain some water of crystallization. So it's necessary that before we begin to use it to prepare our standard solution, we will have to evaporate this water of crystallization. So the 26.5 grams of sodium carbonate we have weighed, we'll place in an evaporating dish, put it in an oven to dry for 10 minutes. You remove and are allowed to cool in a desiccator. After that, you note the weight. Having noted the weight, you transfer the weighed sodium carbonate using a spatula into a clean 250 cm cube beaker containing 50 cm cube of deionized water. To ensure that all the sodium carbonate is transferred, you use a wash bottle to wash the evaporating dish, the spatula, and the rinsing you add to the beaker. Then you stir the solution with a glass rod. Continue stirring the mixture with a stirring rod until the sodium carbonate has fully dissolved. Or if necessary, you want to ensure complete dissolution of the sodium carbonate. Then the solution is then transferred into a 250 cm cube volumetric standard flask by pouring it down the glass rod to a funnel. Using a wash bottle, wash off the solution on the glass rod and the beaker with deionized water several times. The washing is added into the standard volumetric flask. Rinse the funnel with deionized water, allowing the water to run into the flask. Shake to make sure that all solid particles are dissolved. Then add more water from the wash bottle to the 250 cm cube mark on the flask. Stopper and further shake to obtain a homogeneous solution. In that way, you have prepared your standard solution of 1 molar sodium carbonate. So with this, we come to the end of our experiment 1. That is preparation of a standard preparation of a known solution of known concentration using sodium carbonate. Now, our next experiment is experiment 1B, which is preparation of series of solution of different concentration of sodium carbonate. From the 1 mole standard solution of sodium triisobicarbonate prepared in our experiment, we are to prepare a 0.1 mole and 0.05 mole of sodium carbonate. Now, these concentrations are of lesser, these solutions are of lesser concentration. In preparing series of diluted solution, the standard solution from which the solutions of lesser concentration will be prepared, as we know, will have a higher concentration than the diluted one. The standard solution will be our stock solution. A stock solution is a solution from which a dilute solution can be prepared. It is a standard solution. To prepare 0.1 mole and 0.05 mole sodium carbonate, we apply the dilution formula which you are very familiar with. That is C1 V1 equals to C2 V2, where C1 equals to initial concentration of solution, V2 equals initial volume of solution, C2 equals to final concentration of the solution, and V2 equals to final volume of the solution. Now, from the data we have, our C1 is 1 mole. 1 mole we prepared in experiment 1A. The V1 we do not know. That's what we want to determine. The C2 is the final concentration, which is 250 cm cubed, because when we get our initial volume, we will dissolve it in 250 cm cube of deionized water, which is our solvent. So our C2, which is our final our V2 is 250 cm cubed, while our C2 is 0.1 mole, because that is the concentration we are looking for. So now substituting and making V1 the subject of the formula, you will have M2 times V2 all over M1. So when you substitute these data we have, you will get 25 cm cubed. Having determined V1, we will measure accurately 21 cm cubed of the stock solution using a clean graduated, a clean 250 cm cube graduated pipette, or a 25 cm cubed measuring cylinder, and transfer into a clean 250 cm cube volumetric flask, and add distilled or deionized water to the 250 cm cube mark to obtain our 0.1 mole sodium carbonate. Shake the solution thoroughly and stopper. In that way, you have diluted the 1 mole sodium carbonate prepared in the first experiment, experiment 1A. You have succeeded in diluting it to 0.1 molar. The same procedure you follow to dilute to 0.05 mole. All that you need to do is that your C2 you substitute with 0.05 mole. Now we've learnt in the first and second experiment how to prepare a standard solution that is a solution of known concentration, and how to dilute this solution to get solutions of lesser concentration.
Thank you, students. Just as we heard from our instructor, we were told how a standard solutions are to be prepared in the lab. The first thing you need to do is to take your salt, know the molecular mass of your salt, just as we were told from the class. If you look at the body of your plastic or the container, you may see the exact quantity or the mass of the compound. You may wish to use that, but otherwise you can do your own calculation. The calculation of the mass is done by summing up the composing elements. For sodium carbonate, we have sodium as one of the elements, carbon and oxygen. So when you sum up this, you are going to have about 106 grams. So we are going to weigh the 106 gram. This is our balance. So, and this is our evaporating dish. We are going to weigh our salt here. So that we are doing right now. What I'm having here is what we call spatula. It is used to take your salt. You don't have to use your hand. You can see what I'm doing. Okay. Now we have our 106 grams. This 106 grams is going to be taken to the oven where you are going to have it dried. If you look at the body of the plastic, we are told that the percentage purity of this compound is 99.5. It means that for it to be 100, something must be part of it. Therefore, that likely is water. But for us to have the 100% sodium carbonate, that is the reason we are taking this to the oven to have it dried. And when we dry it, we measure it repeatedly until we have a constant weight. So once we have a constant weight of 106 grams, we take it to the lab for our preparation. Right now, we are going to the oven. Now we are back with our salt. This is the salt, having dried it to a constant weight. So now, how do we prepare it? What we do is that you make sure the beaker you are going to use, ensure that it is properly rinsed. You use your deionized water to rinse it properly to ensure that there is no any leftover chemical, either the same type or from another source, so that you don't have to contaminate what you have. So now, I have my salt here that I'm going to pour inside the beaker. But before I do that, I have to add a little water into the beaker. This is my beaker, and this is my salt. So I am pouring it inside the water, the deionized water. Ensure that every bit of it is taken away from the evaporating dish. Otherwise, you will not have exact concentrations from what you prepare. Here I have my stirring rod, which I am going to use to stir what I have poured inside this beaker with water. The water is acting as solvent, just as you were told from the beginning. For you to prepare a solution is a mixture of solute and solvent. Your solute is your salt. Your solvent is the diluent, that is what you use in preparing your solution. Now I have it here. What I need to do is to now put my stirring rod inside it to ensure that this is properly dissolved for us to have a homogeneous mixture. Add more water.
Let Let me give hello.
Now we can see that we have a clear solution, a homogeneous mixture. That is where you can no longer differentiate between the solute from the solvent. Now we have completely mixed solution. Now what we need to do now is to pour it inside our standard volumetric flask, which is 250. So you can see the way I am pouring. Now if you look at this beaker, it has a funnel-like mouth. Hence, I do not need to use funnel for me to introduce this or to pour this inside the standard volumetric flask again. So you can see what I am doing. I'm already pouring it inside. Now we are going to make this up after rinsing the beaker repeatedly to ensure that every part of the chemical I mixed earlier is taken out and poured it into the standard volumetric flask so that we can have the exact concentrations calculated from what we predetermined that, yes, we want to prepare what? 1 molar. So having done that, now I take my wash bottle containing the distilled water and then make it up to the mark. If you look at this standard volumetric flask, there's a round ring, a line ring like dark brown around the neck, showing that this is where we are to stop. That is, when we get to this place, that means we now have a 250 mil in this. Now, there is one mistake that students normally make in the lab. When you are doing this preparation, you are not to do the dissolution inside your standard volumetric flask. You are to do it in your beaker. After doing it in the beaker, then you introduce the mixed salt and the solvent inside your standard volumetric flask. Okay, so we are there. That is at the 250 mark. Having done that, we now keep it aside. What next? The next thing you do is to carry your labeling material. You now write 1 molar sodium carbonate solution and now paste it on the body of your volumetric flask, and that is the end of this preparation of standard solution of sodium carbonate. Thank you. We are coming back to our preparation, having done the initial one, which is 1 molar. Now we need to prepare a lower concentration. How do we do that? We are going to use a formula called serial dilation formula, as you were told from your class initially, and that is M1 V1 is equal to M2 V2. Your M1 is the concentration of your initial solution. Your V1 is the volume we need to calculate, because that is the volume we need to take to prepare the subsequent dilutions, whereas your M2 is the concentration we want to prepare now, and your V2 is the volume of which we want to prepare these intending concentrations to. Now, having done that, what we are going to have is, because we are the one to determine how much of concentrations do we need to prepare now. For example, we are preparing a 0.1 molar of sodium carbonate in a 250 cm cube. Now, what we have from our initial formula given to the serial dilation formula, what we are going to have is V1, which is the volume of the original solution, is equal to M2 times V2 all over M1. Our M2 is the concentration we want to prepare, which is 0.1. Our V2 is your 250 cm cube, which is the level or the volume you want to prepare your 0.1 molar. And your M1, which is your initial concentration, you are going to divide your 0.1 molar times 250 all over 1 molar. When you do this calculation, you are going to have 25 cm cube. What does that mean? What it means is that for your 1 molar sodium carbonate, you need a 25 cm cube mil out of this initial solution to prepare your next solution of 0.1 molar by taking 25 into it and mixing it up, adding water or deionized water to the mark, which will give you your 0.1 molar concentration. Now, for example, because you want to be very careful with what you are doing, you should have your 25 cm cube standard volumetric flask where you are going to use to do your dilutions. Now, you can see this is your 1 molar sodium carbonate. I am taking a little out of it. That is from what we have calculated, we say 25. So I'm going to take the 25 here. This standard volumetric flask is 25 ml. Now this is my 25 ml of 1 molar sodium carbonate. And this is my 250 ml, because this is the volume I want to prepare my 0.1 molar into. So what do? The next thing I do is to pour this 25 ml of my original solution into this. And make it up to the mark. Now, we can see we already have our 250 ml of a 0.1 molar concentration of sodium carbonate. What do you do next? The next thing you need to do is to have it labeled 0.1 molar sodium carbonate. When you do that, you label it and keep it aside. So that is how your serial dilutions of your higher concentrations are done in the lab. For other ones, if you use the formula given to you, you can achieve any dilutions you want to make because it is universally accepted. Thank you.